Hello there. Today we'll be doing distinct sequences. How we'll be doing this problem is pretty interesting because we're going to do it rather humanly because we're given two strings and we're trying to figure out how we can generate rabbit, the second string t, from s. And there are three ways to generate the string rabbit, rabbit, and rabbit. So how does that work? Well, let's think about it like this. If we're going to match a string between the first one and the second one, if they're equal, let's move them forward, I and j. As long as they're equal, we can move these forward. When they're not equal, we have to move the I forward because we're trying to match I to j s to t. So we move I, they're the same, we keep moving, and when they are empty, when we hit the empty spot, then we can return a 1. There's one way to do this. Another way to do this is that when we see that they are equal, we're going to have to add another way of doing this, is that by skipping it, we can also get another way. And the same here, we can try to skip this one, but grab this one, and we can also have another way of getting rabbit. And then once we reach the end, where I is equal to the length of s, we can select that as another way, and add that to our return statement. The thing is, what we need to do is to store the I and the j spot from this particular string, and we store that, and that way we can return, once we see that pattern again, which we will see because we will be having a lot of I and j movements when we see something and we don't see something. We can just return it automatically because the maximum number of items that we can process is the number of i's and number of j's, and that's I times j. It's just yeah. So anyways, a thing to note is that suppose that I is still here and j goes to the end. That means that there's no possible way of getting a item from s to become t. Let's suppose an empty string and let's say s t. So we cannot get an I would be at empty at the end, and tj would still have an item, and that means we should return 0. With that, let's set up our dp is equal to an array, hash map where the key is equal to I and j, a tuple of that, I and j, and the value is going to be a number of distinct ways, number of distinct sequences. Subsequences. And with that, we can define our DFS with I and j in mind and return an int. So let's take a look at the base cases. If length of s, well, I is equal to length of s, that means we reach the end. That means we can return 1. Else if j is equal to length of t, that means we can return 0. Else if I and j is in the dp, so we can return dp of I and j. Right, and now else, this means that we did not hit any of our base cases. That means we have to keep recursing. That means if I is equal, well, s of I is equal to t of j, that means they're equal, and that means we need to dp of I and j is going to be equal to the DFS of I plus 1 and j plus 1 and DFS of I plus 1 and j. Otherwise, we'll just set dp of at that particular place in time equal to DFS of I and j, I plus 1 and j, which we've done earlier with rabbit. After all that is done, we can return dp of I and j because that exists now. And with that, we can return the DFS of a 0 and 0. That's where we begin. And let's run the code. Oh, we have an issue. Let's see. Whoops. It should have been j equals t equals what, return 1. we're returning a number of distinct ways, we don't. So why was it j instead of t? I mean, j equals length of t rather than I equals length of s, which I messed up on. Yes, so if j reaches the end and I is at a particular point, that makes sense, right? If s is still, if I is reached the end and j is still in somewhere in the middle of nowhere, that means we have not found it. I think I mixed it up earlier. Sorry about that. But I think this should work. Perfect. All right. Looks like we have a pretty good solution here. I hope this if statement makes a lot of sense, because these are the possibilities of what will occur and what can occur, and what we're doing. This is slightly slower than the other solutions because this is top down, which means we're going up, we're going from the top down and then bottom up. We're going both directions. If we do a bottom up approach, it will be faster, because we're only going from the bottom all the way to the top. But that also means there's a lot more code that we need to implement. Of course, yeah. But I enjoyed this way of coding. It was much shorter and much more straightforward with thinking. And so I'm going to prefer writing this type of code. If you were to push me to write the other type of code, bottom up, I would have to think about that and move from the end of the strings and move upward. Yeah, a lot of thinking. So anyways, if you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.